Hello again. This is Chaban again. In this video, I'll do the homework from section 10.2, the hypothesis test for the population proportion. Again, as I mentioned before, the population proportion has the symbols P, and we are testing hypothesis for population proportion. Okay, so there is two different ways to test hypothesis. The first one is classical method, other is p-value method. So I'm going to give you a glimpse of each one. So for the classical method, you need critical value z alpha. Just write critical value, that's fine. You need critical value and the test statistics. Okay, test statistics. And for the p-value method, you need p-value and the alpha is called level of significance. Okay, level of significance. So again, if you test a hypothesis by using classical method, we need critical value and the test statistic. I'm going to show you how to find those in these questions. And the p-value method, we need p-value and the alpha. Okay, again, I'm going to show you that as well. So there's two ways you can test hypothesis. So first thing you got to test hypothesis is to identify what type of test is this. So there's three types of tests: right tail test, left tail test, and two tail test. So because of this greater here, an alternative hypothesis H1, because of this symbols, this is called right tail test. This is called right tail test. I write the short form RTT, right tail test, because of greater. Okay, the first hypothesis H0 is null hypothesis. Second hypothesis H1 is alternative hypothesis, and you are given p hat equals 0.18, n equals to 150, alpha equals to 0.01, and you answer the following questions. Part A, determine the critical value or values. I'm going to mention why there is more critical value later. And test statistics, what conclusion must be drawn. You got to answer three part here: critical value, test statistic, and what is the conclusion. And finally, you determine the p-value for the test. So I'm going to show you all in this problem. Okay, now to find the critical value, I first draw the graph. Okay, here's the z-score, and this is the standard normal curve. Okay, this point is z equals to 0. Now, since this is the right tail test, my graph going to be like this. This is the point here, and this value is called critical value. We call z alpha. This is the critical value. Okay, again, the critical value is z alpha. You can see here, determine the critical value. So here symbol is z alpha for critical value. Since this is right tail test, we only have one critical value, which is positive because it's on the right of the 0. So only one critical value in this case. So this area on the right of critical value, let me highlight that. This area is called level of significance. So this area here is alpha. Okay, alpha. What's the value of alpha? Here's a question: 0.01. 0.01. This is the alpha. Again, very important to identify alpha in the graph to find the critical value. So I'm looking for this critical value using this level of significance, 0.01. So area on the left of this critical value, 0.99. Okay, this is the left area. So let me show you how to find the critical value using calculator. So in the calculator, like we did in chapter 9, the critical value z alpha equals to inner parenthesis. You have three numbers that goes under inner. The second number is mean. The third number is standard deviation. The first number has to be the area on the left from this critical value I'm looking for. So this is going to be 0.99. Okay, 0.99 is the left area from this critical value I'm looking for. So if you put that in the calculator, let me do that for you. I should say second VRS, and you see in norm is number 3, and wait, I'm going to clean that here. Oh, number 3, just drawing here, number 3, the in norm, and you put 0.99, which is left area, comma 0, comma 1, close parenthesis. So you get the 2.326. If you round it to 2 decimal places, the instruction says round to 2 decimal places, the critical value is going to be 2.33. So the answer is 2.33 as a critical value. So this value is going to be 2.33. Again, this value here is called 2.33. So we found the critical value using calculator. Also, I'm going to show you how do you find the critical value using the table, which is standard normal distribution table. So since I'm looking for area on the right from the critical value, so I'm looking for this table here. Okay, so this table here, watch this table here. So in this table, standard normal distribution table, this is the critical value on the right side of this standard normal curve. So I'm looking for this table and this value here, because this is matched with this graph. So area on the right here is going to be 0.01. So how much area on the left? So look at here, they give you area on the left. So every area here, those bunch of the numbers are area on the left. So here area on the left is 0.99. So let's find 0.99 area that is on this on here. So let's find 0.99 or close to 0.99. So 0.9901. Look at this value. This value is close to 0.99, right? So this is the area on the left of this critical value. So to find the critical value, you use 2.3 and 0.03. Pretty much you add 2.3 and 0.03, you get 2.33. So that's what you have here. Again, to find the critical value using a table, you have to use the left area because of this chart, this area on the left. So this every area here on the left area like 0.99. So I'm looking for 0.99 here, close to 0.99. We don't have exactly 0.99. So critical value is going to be 2.3, and you go up here 0.03, you add 2.3 and 0.03, you get 2.33. Okay, now I'm going to show you how to find the test statistic, which is Z0, and also we call Z as a Z0 as a test statistic because calculator gives you Z value. So to find the test statistic, we use a calculator function. Let me write down here to find Z0 test statistic. We use stat test number 5 in the calculator. So number 5 is 1 prop Z test. Again, this is the calculator function to test the hypothesis for proportion. Okay, so let me go back here. I'm gonna open that function, start, I go to the test number 5. So now you have a function here. So what is P0? P0 is same as P here. Again, this is called claim value. I'm writing P0 is same as P. That's the same. Like Z0 is same as Z. And let's put that value in the calculator. Okay, so it's going to be 0.13, and then x value is, I don't have x value here directly, but notice that x value, x equals to p hat times n. So you multiply p hat and n because you have p hat here and here. So you can type directly here. What's the p hat? 0.18 multiplied by n value is 150. That's the x value, and it's just simplified by itself. 27. N is 150. And the calculator and the prop, this is right tail test, so this is the grader, so you have to choose this option, grader, here. So go to the third last one and press enter. This is going to be highlighted, which is for right tail test, and scroll down to calculate, enter, and you get this value here. So you have a bunch of the number here. The first number is test statistics, which is z, is same as z0. That's what we're going to put here. It's going to be 1.82 rounded to 2 decimal places. 1.82. So in the meantime, in the same window, you can find this p equals to 0.0343. That is called p value. So for part B, p value, you have to answer that. So I'm using this number p as a p value, 0.034. So 0.034 as a p value. So that's how you find the test statistics and p value using the calculator function, which is one prop g test. Okay, now the big part here is conclusion. Okay, what's the conclusion should be drawn? Okay, again, to draw the conclusion, there is two ways to check it. One is p-value method, other is classical method. So let me show you classical method. In the classical method, I mentioned before, you need critical value and test statistic to test the hypothesis. So let me do classical method. Okay, this is called, whatever you see green one, this is called do not reject reason. This is do not reject. I said do not reject. And this reason here is rejection reason. Okay, the red one is rejection reason, reject. So I'm supposed to reject here, R-E-J-E-C-T, reject. So again, this is do not reject. This is the blue one, sorry, the green one is do not reject, the red one is reject. So the question here is Z0, is Z0 in the rejection region or not? That's what you're looking for. If Z0 is in the rejection region, also called critical region, by the way, and if Z0 belongs to the rejection region, you reject null hypothesis. If Z0 does not belongs to rejection region, do not reject null hypothesis. So that's what I'm checking here. So what is 1.82 belongs to? Obviously 1.82 belongs to here, right? Since this is 2.33, so 1.82 is somewhere here. So I'm going to say here is, let me put down here. This is here. This is 1.82. That's the critical value. Sorry, that's the test statistics. So is Z0 in the rejection region or not? Answer is not in the rejection region. You see here, this is the rejection region, but this is not rejection region. So you do not reject. Answer not. So we do not reject. Okay, we do not reject. We do not reject null hypothesis because this is not in the rejection region. In other words, you can see that Z0 is less than Z alpha. Again, Z0 is 1.82, Z alpha is 2.33. So this is smaller than Z alpha. So it does not belong to the rejection region. So you do not reject the null hypothesis. So that's the classical method. And when you answer the question, your answer must be do not reject the null hypothesis. So if you do not reject the null hypothesis, there is insufficient evidence to support alternative hypothesis. That's the conclusion. it also comes from 10.1. If you remember that, if you do not reject null hypothesis, what's the conclusion? There is not sufficient evidence to support alternative hypothesis. So C is the correct choice for this questions. So this is the classical method. Okay, this is the classical. So p-value method is this. So if you use p-value method, you look for p-value and alpha. Okay, let's compare. What's the p-value? 0.034. What's the alpha? Alpha is level of significance. Here 0.01. Obviously you can see here, which is right area, 0.01. And which is greater? Is p-value greater or alpha greater? Looks like p-value is greater than alpha. So if p-value is greater than alpha, if p-value is greater than alpha, the conclusion is do not reject. Do not reject null hypothesis H0. So again, doesn't matter which way you do, either you do classical method, still you say do not reject. If you do p-value method, still you see do not reject null hypothesis. Okay, this is quite long answer of this question number 1, because I did multiple ways to show the questions. I hope you understand. Question number 2. Consider the following hypothesis. H0p equals to 0.62. H1p does not equals to 0.62. Because of not equals to in H1, the symbols tells you this is two-tail test. I call TTT, two-tail test. Again, it has two-tail test, so it must have two critical value. We're expecting two critical value. And you're given p hat, you are given n, and you are given alpha, which level of significance. So you answer what are the critical values, test statistics, and conclusion, and determine the p-value for the test. Exactly same as before, but this test is two-tail test. Again, I told you p is same as p0. That's called claimed value. All right, before I find everything, I'm going to tell you how to draw the graph for this test. So this is the z, and this the graph looks like this is called standard normal curve. So this is the two-tail test. Unlike the first one, if you remember the right tail test, you only have area on the right, only one area. But there is two-tail test, you're expecting two area on each side of the graph. So here it looks like this is the call. This is two-tail test. There's 2 points here, and this is gonna be area on the left, and this is gonna be area on the right. So this value here is critical value on the right, and this value is critical value on the left. So this value is called z alpha over 2. This value is called negative z alpha over 2. Z alpha over 2. So this is the left critical value, this is the right critical value. I'm looking for both critical value because the question tells you determine the critical values of the test. So I'm going to find both. So to find this critical value, I need how much this area on this side and how much area on this side. So notice that level of significance alpha is 0.05. So this total area, this area plus this area is 0.05. So each area is going to be 0.05 divided by 2. Okay, again, total area here is 0.05 on each side. Okay, each tail total area is 0.05. So this area is going to be 0.05 divided by 2 is going to be 0.025. This is going to be 0.025. So that's what I'm looking for. I'm going to show you how to find this critical value using calculator and also table. Let's find this critical value. Okay, let's find this value, and to find this critical value, negative z alpha over 2, you use inner parenthesis left area comma 0 comma 1. Again, this is similar. Under inner you input left area is 0.025 from this points here, and 0 is a mean and the 1 is the standard deviation. So if you use that, in the calculator, you get critical value using calculator. Also, I'm going to show you table in a minute. So you do second VRS, and the in norm is number 3. So you put 0.025, 0.025, comma 0, comma 1, close parenthesis. You get negative 1.96 if you round it to decimal. Okay, so this value is negative 1.96, and this is this critical value. And other critical value by symmetric has to be other side at the same distance from center, and this critical value must be positive 1.96. so you have two critical value, negative 1.96 and positive 1.96, and you type that in the box here, negative 1.96 comma positive 1.96. okay, now let me show you how to find the critical value using table. Let's find this critical value, and I'm going to find that it has to be positive of this value. So let me find it here. That is called normal distribution table. So here's the, look at this guy. Okay, here. So I'm looking for not this one, because this is the right critical value. To find the left, I'm going to find another graph here. It's supposed to be somewhere here. Watch here. See, this area here is similar to this area. So everything here is given as a left area on the tail. So I'm looking for 0.25 here on the list, and I'm going to read that number on this side, the heading number, this and this. So let's find 0.025 area. 0.025 is 0.025. Let's see, 0.025 here. See, this is the 0.025. That's exactly the area here. So you critical value negative 1.9 and 0.06. So this gives you negative 1.96. You see that? Again, one more time. This is the, what is the 0.025? 0.025 here. So I'm looking for negative 1.9 and 0.06 gives you 1.96, but negative because of negative on the critical value on the left. Other side going to be positive 1.96. That's how I find the critical value. So in the test statistics, we use a calculator like it before. To find the test statistic, we use stat test number 5 like we did in previous question. So you're going to do this calculator here. So you go to stat test number 5, and you put the value. Let's see what we have here. Let's see. This gives me p0 equals 0.62 with the 0.62 parenthesis, and then x is not given directly because there's a formula to find x, p hat times n. The p hat is 0.56 times the n here is 100. Enter, and you still get 56. N equals to 100. And go to the next here. The next line you have to choose what tell test is this, because this is not equals to. This is two tell test. So I highlighted this and I enter. So this is going to be highlighted. I go to the next arrow to calculate, and this enter, and that's the test statistic. Z equals to negative 1.24 if you round to decimal. Okay, negative 1.24. That's the test statistics. So at the meantime, I can find the critical value also, p value also for part B. And again, this is the p value. We just say p here in the calculator. 0.216 rounded to 3 decimal places is going to be 0.216. So 0.216. So I found the all critical value, test statistics and p value. And now finally let's draw the conclusion. Okay, again, there's two ways to draw the conclusion. You use classical method or p-value method. Let's use a classical method. This is here the green one, do not reject here, and the red one is rejection reason. Okay, the rejection reason, also called critical reason. So this is do not reject here. I'll just write here do not reject. Okay, do not reject, and other side is reject. So let's see, where is that test statistic? Where does Z0 belongs to? Is Z0 belongs to in green region or the red region? Let's say negative 1.24. Negative 1.24 is this is 0. Remember that this value is negative 1.96. So here is negative 1.24. Okay, that's the critical value. It's test statistics. So test statistics is here. Again, this value is negative 1.96. So this is supposed to be negative 1.24 is here, somewhere here. So test statistics does not belongs to the rejection region. It belongs to do not reject region. It does not belongs to rejection region. So do not reject null hypothesis. So the answer is do not reject null. So here two options here, do not reject null, and if you do not reject null, there is insufficient evidence to support the alternative hypothesis. The answer is part C. Also you look for p-value. Let's see p-value method. So p-value going to be 0.216. Alpha level of significance here is 0.05. Of course you can see here 0.05, 0.05. So p-value is greater than alpha. So since p-value is greater than alpha, you do not reject null hypothesis. There's two ways to do it. Okay, there is null hypothesis. So that's the question number 2. Question number 3. The Measuring in Money study by Salime from December 2015 shows that the most college students manage their credit card in a reasonable way. It shows that 24% of the students who own credit cards make partial payment that exceed the minimum payment due. So 24% students pay the partial payment more than minimal payment. That's what it says. So 24% is going to be claim value. So here P equals to P0, which is going to be 0.24. Okay, that is given. You are curious to find out if the proportion of the students who make a partial payment that exceed the minimum payment amount has decreased since 2015. So here the clue word here, decreased since 2015. So you are trying to test if this 0.24 is still going to be true proportion, and you want to test if you want to find the evidence to support if the credit card payment that exceed minimum has decreased since 2015. So decrease word here is less than, so you have to find the less than in the alternative hypothesis. To check that, they collect the data from the sample of 380 students. So n equals to 380, and you find that 72 students are making partial payment on their recent credit card that exceeds minimum payment due. So here x equals to 72, and you can test the hypothesis using level of significance 0.01. So alpha here is 0.01. So you have this information here. You complete part A through B here. So but A has multiple part here. So first thing is you got to find the hypothesis in the symbolic form. So here population parameter is P. So this is the first choice here, because again null hypothesis is proportion equals to 0.24, always equals here. But alternative hypothesis, that's what we want to try to find the evidence to support. P is less than 0.24 because of the word decrease. So part A, we determine the null hypothesis and alternative hypothesis. Part B, determine the critical value of the test statistics. So this is the test which is called left tail test, because it has a less than symbols, left tail test. Because of left tail test, it has only one critical value called G alpha. So what I'm going to do here is I'm going to draw the graph first. It's called standard normal curve. This is the Z. So that's the graph looks like. And this is critical value Z alpha, which is going to be critical value. And this area here is level of significance, which is given as 0.01. Again, this area on the left is 0.01, which is level of significance. So this test has only one critical value because this is left tail test. Okay, obviously this is 0 here, which is the mean of this distribution. So first question, determine the critical value of the test statistic. So in this question, to find the critical value, use either table or calculator. If you use the calculator, you find Z alpha using inner parenthesis left area comma 0 comma 1. Okay, but on the left of this points, the area going to be 0.01, so it's just 0.01, and you use a calculator. Let me show you how you get that. So you do second BRS, and you get this option. Number 3 is inner, so you use left area, you type it point let's see here, 0.01 comma 0 comma 1 close parenthesis. So that's the critical value, negative 2.33. if you run it to two decimal places, negative 2.33, because this critical value is left side of 0, and negative makes sense. So the critical value is negative 2.33. So let me write down here, negative 2.33. that's the critical value. So 2.33 negative, that's the critical value. So let me show you how to find the critical value using the table, a standard normal table. And you need the area on the tail. In this case you need the left area. So you go to the table here. So if you see the table, and this area here is 0.01 from the left of this value, which is critical value. So I'm looking for 0.01 area here, or close to 0.01. let's see. So 0.01, so see this one here, 0.0099 is close to 0.01. this one is closest to 0.01. so your critical value is going to be negative 2.33. again, one more time, this is the area which is close to 0.01, and this is critical value is negative 2.33. that's how you get this critical value using table. So that's how you find the critical value using table and the calculator. Now let's find the test statistics. To find the test statistic, as before, we use a calculator. So I do start test number 5. P0 here is 0.24. That's the population proportion, also called claimed value. 0.24 parenthesis sample size, x value is 72, and the sample size is 380, and this is the left tail test because of less, so you have to choose this second option because of less here. So go to the next one, enter. So you scroll down to calculate. So if you highlight calculate, enter, so you get test statistics is negative 2.30. It depends on how many decimal, 2 decimal, so negative 2.31. okay, negative 2.331. so finally at the same times you can see that p-value here for this test. So p-value going to be 0.010549, but rounded to 4 decimal places, going to be 0.0105. So the p-value going to be 0.0105. okay, again p-value and test statistics you can get from the calculator. Now to draw the conclusion, to determine the conclusion, you got to see a graph here, and this is the green one, which is do not reject here, do not reject. This is not rejection reason, but this side here on the left of critical value, this is the critical reason you reject here. okay, so there is 2 sections here. This section on the right of the critical value do not reject, on the left you reject. Again, what's the critical value here? We found the critical value, negative 2.33, negative 2.33. So now let's look for the test statistics. This test statistics is in somewhere here. Let's see where it is. Is that on the rejection region or do not reject region? Let's see, negative 2.31. So negative 2.31 is here, very close to negative 2.33 on the right. So let me label it again. This is going to be negative 2.31. Since test statistics is in do not reject reason, you do not reject null hypothesis. So here is do not reject null hypothesis. So you got to choose one of the options. Say do not reject. So reject is not correct choice. So which one is correct? So do not reject null hypothesis, and the conclusion is going to be, if you do not reject null hypothesis, there is not sufficient evidence to conclude the proportion of the students who make their partial payment that exceed. I think there is something cut off here because when I do the PDF from the MyLabs, so there's some sentence behind that. Okay, but that's the answer. Okay, there is not enough evidence to support alternative hypothesis, which is less than 0.24. Okay, answer is A. Because B said there is sufficient evidence. That's not correct. If you do not reject, there is not sufficient evidence. So A must be the right choice. So that's how you check the hypothesis using classical method. Also, you can use p-value method. As I said before, you can see by yourself. The p-value is going to be 0.015. The alpha going to be, this is p-value. The alpha going to be 0.01. So if you notice here, Obviously p-value going to be greater than alpha because this is 0.01000 as an alpha, but p-value is larger. So if p-value is greater than alpha, you do not reject null hypothesis. That's another way to check it. So that's the question number 3. Question number 4. This is the definition of questions. Determine if the following statement is true or false. When the testing hypothesis using p-value approach, the p-value is large, we reject the null hypothesis. So in other words, say if p-value is greater, obviously large means greater than alpha. If p-value is very large, you do not reject. So remember that we always all of the 3 questions before say do not reject. So since p-value is greater than alpha, you do not reject. So if the p-value is large, you do not reject the null hypothesis. So this is false. Okay, you say reject the null hypothesis, so this is going to be false. Question number 5. A certain drug is used to treat asthma. In the certain clinical trial of 23 of 228 treated subject experienced headache based on the manufacturer. So here x value is going to be 23 and n is going to be 288. So out of 288, 23 experienced headache from that drug. The accompanying calculator display shows from the test the claim that less than 11% of treated subjects experience headache. So here less than 11% is going to be alternative hypothesis. So if you want to write the hypothesis, it's going to be looks like this. Let me write the hypothesis for this case. H0 proportion equals to 0.11, H1 P less than 0.11. This is called left tail test, LTT. So that's the hypothesis looks like, but you don't have to write here. In the question asking for is that the left tail, two tail, or right tail test. So obviously because of less here, because of less than 11% you see here, this is called left tail test. The first part A answer is left tail test. So what's the test statistics? You can see from this window display here. Test statistics equals to negative 1.63, negative 1.63 rounded to 2 decimal places. You don't have to use a calculator. You can see directly from the window. What's the p-value? This is the p-value 0.051, 0.051, and again 0. No, 1, because you don't do 4 decimal places. 0.5111. Okay, that's the p-value. And what's the null hypothesis, and what do you conclude about it? So again, I wrote the null hypothesis here. Null hypothesis must be p equals to 0.11. That's the null hypothesis, because null hypothesis always parameter equals to claimed value must be equal in the null hypothesis. So do you reject null hypothesis or you do not reject? Let's see, what's the p-value? The p-value going to be 0.0511. What's the alpha? The alpha is given as level of significance. That's the alpha. It doesn't give you symbols, but it's a level of significance. Alpha is 0.05. So which is greater? Obviously p-value is greater than alpha, so you do not reject. Okay, do not reject. Null hypothesis H0. Also another word for do not reject is called fails to reject. Okay, fails to reject null hypothesis. So you choose the answer here. So say this is the reject, and reject is not correct choice here. So first to reject the null hypothesis because p-value is greater than level of significance. That's obviously B is a choice here. So but we just mentioned here. So next question, what's the conclusion? If you do not reject, you can say there is not enough. Do not reject means there is not, okay? There is not sufficient, also we can call enough evidence to support H1, where H1 is P less than equals to 0.11. So let's choose the answer. So do not reject means there is, it's not wrong choice. There is sufficient, that's the wrong choice. One of those is going to be the answer. There is not sufficient evidence. B says that. D also says there is not sufficient evidence. But you look for the next sentence after that. There is not sufficient evidence to support the claim less than 11%. Treated subject experience headaches. So this is the answer for choice for this part E. Okay, that's the final conclusion. Question number 6. Test the hypothesis using p-value approach. Be sure to verify the requirement for the test. So the requirement for the test is going to be, this is the one of the main requirement, n p0 1 minus p0 greater than or equals to 10. That's the main requirement. So if you substitute the value and to see if this is true, then you say, is that true? That's first question. Your answer is n p0 1 minus p0 greater than or equals to 10. Let's see that. N value is 200. The p0 is same as p. I mentioned that before. 0.1 1 minus 0.1 greater than or equals to 10. So let's do simplify this. What do you get? You get 18 is greater than or equals to 10. This is true. So is that true? Yes, it is. So what's the p-value? So again, use this information, n, x, and the p0 in the calculator. Use calculator. I'm not going to do that because I did a couple of questions before. Calculator. Use start test number 5, and you get the p-value, which is going to be 0.009. So let's see, do you reject or do not reject? Let's compare p-value with the alpha. P-value and alpha, let's compare that. P-value is going to be 0.009. Alpha is going to be 0.10. Okay, see, 0.1100. You can say that if you like. So obviously p-value here is less than alpha because 0.009 is less than 0.100. So p-value less than alpha. So we reject the null hypothesis because p-value is less than alpha. Okay, less than alpha. That's the answer for the last part of this question number 6. Question number 7. Again, test the hypothesis using p-value approach. So you're looking for p-value. Obviously, you don't have to find the critical value and test the statistics. You just need to find the p-value here and look for alpha. So you put this data in the calculator. I'm not going to do that. I did that before. This is obviously less than here. So this is the left tail test. Use calculator. Use CLC calculator to find p-value. What's the calculator function? Calculator function is start test number 5. Start test number 5, and you input all the data value here. Make sure that you choose the left tail test symbols, less than symbols in the calculator, and you find the p-value. So in this case, p-value going to be 0.0374. That's what you get. Again, you pause the video and you do yourself and you'll find that. Now let's compare. You don't need to find the critical value and test the statistic. It doesn't test you to find that, so you're just looking for the p-value. Let's compare p-value with the alpha. So p-value is going to be 0.0374. The alpha is going to be 0.01. So obviously p-value is greater than alpha. You guys see that 0.0374 is greater than 0.01. So p-value is greater than alpha. You do not reject. Okay, do not reject null hypothesis. So you have to choose the option here. So this is a reject, this is incorrect, this is a reject as well. This A and D incorrect choice. You do not reject null hypothesis. So why? Because p-value is greater than alpha, which is B is our choice here. Okay, because p-value greater than alpha, you do not reject. Okay, question number 8. Test the hypothesis using p-value approach again, but here you got to find the test statistics as well, and also p-value, and more you have to find p-hat as well. So again, everything you can find from the calculator, but I'll have to check this criteria: np0 1 minus p0 greater than or equals to 10. Is that satisfied or not? And you put the answer yes or no there. So let's find np0 1 minus p0 is greater than or equals to 10. So how much this value going to be? Let's find this value. N going to be 500 and p0 going to be 0.76. 1 minus 0.76, this equals to. So if you simplify this gives you, and round it to the do not round. You write whatever you get from this everything. Do not round. Your the value going to be 91.2. Okay, use a calculator. This value is 91.2. So it's greater than 10. So you say yes, and this is 91.2 because is this greater than 10? Yes, because this value is going to be 91.2, which is greater than 10. Now, what's the p-hat? Again, p-hat is going to be, you can find from the calculator, or you can use the formula x over n as a p-hat. X value here is 370 divided by n is 500. If you divide 370 by 500, you get 0.74 as a p-hat. But you can find this p-hat, all this in the calculator. Let me show you. Again, use start test number 5. Let's see, start. Go to the test here, clicking this arrow, number 5. So you get p0 is 0.76, enter. X value is 370, enter. N gonna be 500, 500, enter. So you choose the to-tell test because not equals to, so you have to select this first one, enter. So this selected, go to the next, calculate and press enter. You get, see, p-hat 0.74 from here as well. That's what we get here, 0.74. So what's the test statistics here? Z as a test statistics, also symbol Z0, and p-value over here. So everything from the calculator, you get it. So let me write down here, and the test statistic going to be negative 1.05, and the p-value going to be 0.295. Again, let me show you. Is the same one? Yes. Let's see here. Test statistics is negative 1.05, round to 3 decimal. P-value going to be 0.295. Okay. So now let's draw the conclusion. You reject or do not reject using p-value method. So let's compare p-value and alpha. Okay, what's the p-value? P-value going to be 0.295. The alpha is going to be 0.100. So obviously p-value is greater than alpha, you say do not reject. Okay, do not reject. Do not reject null hypothesis A0. That's the conclusion. So you choose do not reject here. Do not reject because p-value is greater. Okay, greater than alpha, you see here. Okay, that's the question number 8. 9. Number 9. Researchers selected 336 patients at random among those who take certain widely used prescription drug daily. So here 836 is sample size, n equals to 836 because that many people research selected. In clinical trial, 23 out of 836 patients complained flu-like symptoms. So 23 people here who complain as a symptom is going to be X value. Suppose that it is known that 2.3% of the patients taking competing drugs complain of flu-like symptom. So here 2.3 going to be 0.023. That is called P here, which is same as P0 is claim value. Right? Again, suppose that it is known that this is the null hypothesis, P equals to 0.023. Is the level of significant evidence conclude that the more than 2.3% of the drug, look at the word more than here, okay? Because of more than, this is called right tail test, greater. So user experience flu-like symptoms as a side effect, alpha equals 0.01 level of significance. That's the question. So if you write the hypothesis, it's going to be looks like this. H0 null hypothesis, P equals to 0.023, and then H1 P is 0.023, the same claimed value, but this here is more than, so you get greater. So this is called right tail test, by the way. So now you got to check the criteria here. So you're writing what is NP01 minus P0 value. So I'm gonna do the math here to find it. NP01 minus P0 equals to N is 836. P0 is gonna be 0.023 and 1 minus 0.023. So if you simplify this all, you get this 18.8. Okay, so this value is going to be 18.8. You put in the box here. Okay, you round it to 1 decimal places. Okay, by the way, this is not 0 here. Okay, my bad. Only sample size 836. Okay, 836 here. So I put that NP01 minus P0 value, which is going to be 18.8, 1 decimal places, and you have to select a bunch of the options from drop down menu. So this is greater than 10 and the sample size is less than 5% of the population size. There is another criteria, n has to be less than 5% of uppercase n. So this is another criteria must be satisfied to test the hypothesis for population proportion. It's not mentioned before, but now it is mentioned here, so you have to write it down. The sample size is less than 5% of the population size, and the patient is in the sample were selected at random. Okay, again, the selection of the sample size must be random, so you have to select the word where here to make sense to this sentence. All the requirement of the testing hypothesis are satisfied. Okay, again, this is just basically you completing the sentence that makes sense so that you can test the hypothesis using whatever method you like to do. So that's how you answer the first part of the question. Now, what are the hypotheses? Again, I wrote the hypothesis here, and you select the option A0 P equals to I don't know what's there's an option and drop down menu. So it looks like this. A0 P equals to 0.023, and versus H1 P is greater than 0.023. Okay, that's how you select. So find the test statistics. So use the calculator to find the test statistics. Again, I did that before. So use that information. Use information here, right? Here to test the hypothesis using p-value method. So you'll see that what's the test statistics. This has to be 0.87. Okay, 0.87. That's the test statistics, and the p-value going to be 0.192. Again, I want to show you, if you want, just let me show you here. So you do the start test number 5, and the p-value going to be 0.023. Sorry, p0 going to be that, x going to be 23, and the sample size going to be 836. Enter, and this is greater, so use a greater right tail test, and go to the second and calculate here. So this is p-value. Let me see. So p-value is 0.192, and the test statistic is going to be 0.87, rounded to 2 decimal in this case here. And but remember that p-value rounded to 3 decimal, test statistic rounded to 2 decimal. That's the answer. So what happens if p-value is greater or alpha greater? Let's see. P-value is going to be 0.192, alpha going to be 0.01, so 0.01. So since p-value is greater than alpha, you do not reject. Okay, do not reject null hypothesis. So the drop down menu gives you to choose what you need to choose from. Since p-value is greater than alpha, do not reject. Also called fails to reject. Okay, fails to reject null hypothesis. And so if you do not reject null hypothesis, there is not sufficient evidence at alpha is 0.01 level of significant to conclude that more than 2.3% of the users who take the prescription drug daily complain of flu-like symptoms. So that's how you conclude. There's just a bunch of the option in drop down menu. You select the right one based on your work. Okay, that's the question number 9. Question number 10 is similar. I'm not gonna do all. I'm just gonna give you the information that you need to input in the calculator. So here you read question carefully. So this is the proportion. Has to be p0 is going to be 0.38. That's the proportion they give you. And suppose that the random sample of 110 traffic fatalities, so n equals to 110, and x value going to be 51. So you have this information so far from this sentence here. From here, let me highlight that. Suppose random sample of 107 traffic fatalities in certain region with a large population, result 51 of them involve positive BAC. Okay, does this sample evidence suggest that the region has a higher? What's the word here? Higher. So the higher is important. This is for alternative hypothesis. Higher is greater than. So when you write the hypothesis, you use greater symbols in alternative hypothesis. So how do you write a hypothesis? H0 P equals to 0.38. H1 P is greater than 0.38. So you use this information, and remember that alpha here is going to be 0.05. So use this information to put in the calculator, and you check the criteria as we did it before in question number 9, and you find all test statistics, p-value, and you draw the conclusion just like before. So I'm going to leave this question for you. Okay, question number 10. Question number 11. It is similar to question 9 and 10. Let's see what can I do with this question here. Maybe I have to give you information that is provided in this question. Let's see. 20 years ago, 56% of the parents of children in high school felt it was a serious problem that high school students were not being taught enough in math and science. So this 56% here is phi. So phi here, same as p0, equals to 0.56. So when you write the null hypothesis, you're going to get H0 p equals to 0.56. Okay, a recent survey found that 288 of 800 parents of children in high school felt it was a serious problem that high school students were not being taught enough in math and science. So here, out of 800, this is sample size, 288 found it was a serious problem that high school students were not being taught enough math and science. So last part of the sentence say, do the parents feel differently today? So here, differently means it's not greater than, it's not less than, it has to be not equals to. So when you write the alternative hypothesis, this is going to be versus, I can say H0 versus H1 dot p 0.256, but not equals to, because it's or differently means not equals to. That's why I use not equals to in the alternative hypothesis. So you have the information here. Postal level of significance is alpha equals to 0.05. That's also given in the question. So let's test the hypothesis. First, you test the criteria. So n p 0, 1 minus p 0. You put the value of n is 800. The p is 0 going to be 0.56. 1 minus 0.56. And if you simplify this, you get to round to 1 decimal places. This is going to be 197.1, which is greater than or equals to 10, obviously. So criteria satisfied. So here in the box you type 197.1, which is greater than or equals to 10. The sample size is less than 5% of the population size, and the sample is random. Again, you choose from the drop down menu. The requirement of the testing of the hypothesis are satisfied. It's like previous question did before. So what's the hypothesis? You write the hypothesis. You write p equals to 0.56 versus h1 p different than, which is not equals to 0.56. So use the test statistics and the p-value using calculator. So I'm going to do that, I guess. So let's do this here. So that's the data here. I'm gonna put the calculator. You just start test number 5. So 0.56 is p0. Okay, now x gonna be 288 over here. 288 enter, and the n value going to be 800, and now test going to be 2 test not equals to, so I select this one and go to the next one, calculate. So you see this number here. So test statistics is z, which is negative 11.40 if you round it 2 decimal places, and then p-value going to be, if you round 3 decimal, notice that this is p-value 4.49 e to the power negative 30. That means you move the decimal 30 units to the left, so you have 0.000290 is the p-value. So p-value basically is 0. So when you write the answer, test statistic is going to be negative 11.40. P-value going to be 0.000. You can type just 0 if you like. So let's see what you're going to do. You reject or do not reject. So p-value and alpha, let's compare. P-value is 0. That's what we had here. Alpha equals to 0.05, less than alpha. So you means reject the null hypothesis. So reject H0, which is P equals to 0.56. The first choice here, do not reject, is incorrect. This choice, first two choices are incorrect. Okay, these are not the right answer because they say do not reject. So one of them going to be true. Again, since p-value is less than alpha, so you choose the C. Of course, D is not correct because D say p-value is greater than alpha. That's not correct. So C is the right answer. P-value is less than alpha. Reject null hypothesis and conclude that there is sufficient evidence to that parent feels different today. That's the alternative hypothesis. If you look at the last phrase here, parents feel different today. That's the alternative hypothesis. There is enough evidence to support, or there is sufficient evidence to support alternative hypothesis. So you reject the null hypothesis because p-value is less than alpha. That's the question number 11. Question number 12. Again, is similar to other one. So what I'm going to do here, I'm writing the information for this one, and you guys do the same thing. So I think this is question number 12 is like flu-like symptom is same as question number 9. Looks like you have repetition of the problem. I'm not going to do that because this is similar to question 9, and we did that. Okay, we did question 9 before, so you should be fine. So question number 13. In previous year, 61% of the women aged 15 or older lived alone. So 61% represent the population proportion P here. So I should say P equals to P0 equals to 0.61. Okay. A sociologist tests whether this percentage is different today. Sociologist wants to know, is that going to be different today? So sociologist is interested, is that P going to be not equals to 0.61? So the sociologist experiment is to find the evidence to support, is that P going to be not 0.61. So to write the hypothesis, we're going to write H0 P equals to 0.61, but sociologists want to find the evidence to support P is 0.61, not that. It's like different today. So because of different, I use the word not equals to. This is the two-tail test. So to do the test, what sociologist does, they get the sample of 750 women. So n equals to 750, the sample size, n equals to 750. And they found that out of 750, 460 living alone. So X value is 460. And the question actually, is there sufficient evidence at the level alpha 0.1 to conclude the proportion has changed? That's what I want to see. Is there enough evidence to support this H1? So here alpha equals to 0.10. Okay, so again, you verify the criteria, you do all like before. So use a calculator and you finish yourself like we did before. Okay, you finish yourself. Again, use start test number 5, and this is, remember, that's a two-tail test. So use not equals to. That's question number 13. Question number 14. Several years ago, 42% of the parent with the in the grade K-12 was satisfied with the quality of education the students receive. So 42% is represent population proportion, P equals to P0, which is going to be 0.42. A recent poll found that 499 of 1065 parents with children K-12 satisfied with the quality education of the student received. So here the information you have is 1065. Among the 1065, this is the sample size, and they found that 499 satisfied with the quality of education. So question cell tells you construct 95% confidence interval to assess whether there represent evidence that parent attitude towards the quality education have changed. So here the alternative hypothesis has an equality not equals to, because they have changed. It doesn't tell you greater than, it doesn't tell you less than. Have changed means not equals to. So how do you write the hypothesis? Here is the hypothesis. H0 P equals to 0.42. This is several years ago. It was this proportion. Now we want to try to find the evidence to support if this has changed. Now P is different than 0.42. This is called two-tailed test. Okay, now you can write null hypothesis and alternative hypothesis. I wrote it here, just fill in the blank here. So but remember that this question is asking to find the upper bound and lower bound. So basically for two-tailed test, you can test hypothesis by finding confidence interval. So I'm going to ask you to refer to the section, see section 9.1, see section 9.1, how we find the confidence interval for a population proportion. That's what I'm going to do here. So to find the confidence interval for population proportion, I'm going to show you. You might remember that otherwise. So you could do start test A. That's the option. Start test A. Okay, I'm going to use that, and I will show you what to do next. Start test A. So I'm going to put the value here. The X is going to be 499, and the N going to be 1065. Enter. Confidence level going to be 95. That's what say here. Construct 95% confidence interval. So you put 0.95. Enter. So you do calculate, and you can see that this is the lower bound going to be rounded to 3 decimal, going to be 0.439, right? 0.439, and upper bound is going to be 0.499. So I'm going to put that number here. Let me write here. 0.439 lower bound, upper bound is 0.499. So let's see after that how you conclude the conclusion. So here's the thing. Let me write here. So this is the upper bound, 0.499. This is the lower bound, 0.439. Okay, you guys see that? This is the confidence interval. This is the lower bound, 0.439, upper bound, 0.499. So ask yourself, does this interval include P0? Does this interval include P0, which is population proportion? But let me tell you before, this interval region is called do not reject region. The outside of the interval is called reject region. If this P0 belongs to inside the interval, that is, we do not reject the null hypothesis. If P0 belongs outside, you do reject the null hypothesis. In this case, P0 here, 0.42, which is where? 0.42 is here. 0.42 is here, okay? 0.42 here. So, since 0.42 is outside the interval, in the rejection region, So you reject null hypothesis. So the answer is C. Since the interval does not contain the... Okay, since this 0.42 is not on the interval, that means on the rejection region, so you reject null hypothesis. So we call there is sufficient evidence to support H1. That's the part C for this question. Okay, number 15 and 16 are the definitions, the last two questions. Number 15 is explain what is a p-value is. What's the criteria for rejecting null hypothesis using p-value approaches? So again, you have to read the definition for the p-value in the notes or PowerPoints. The p-value is the probability of observing sample statistic as extreme or more extreme than the one observed under the assumption. So again, you have to look for the definition in the PowerPoints. Okay, so for rejection, if p-value is less than alpha, you reject the null hypothesis. That's the B answer. P-value less than alpha, reject the null. P-value greater than alpha, you do not reject the null. That's what we did before. So that's the question number 15. Question number 16. Explain what statistical significance means. Again, you read the definition on the textbook or in the PowerPoints. I'm going to give you answer. Statistical significance means that the results observed in the sample is unusual when the null hypothesis is assumed to be true. Okay, that's the E choice for question number 16. All right, that's all about this homework. Thank you for watching.